Okay, this is the first lesson on a three-part lesson on pressure. So in this three-part lesson, I will not be focusing on trying to give a full lesson on pressure, but instead I would like to give an overview of pressure after you have already learned the chapter, and also to address the issues that students normally have problem with. So without further ado, I will start by giving an overview. Okay, so I'd like to divide pressure into three main types: those related to solid, those related to liquid, and lastly related to gas. So the first thing you will realize is that there's one formula that applies to all states of matter, and the formula is pressure is equal to force divided by area, which is given in this equation here. So this formula is applicable not only to solid but also to liquid and gas. Okay, so moving on to the second rule, the next thing you will learn is that there's another formula that will be associated with only liquid and gas, and that is pressure is equal to H rho G. H is the height, or sometimes known as the depth. Rho is the density, while G is the gravitational field strength, and it's only applicable to liquid and gas. Okay, moving on to the next row. From these formulas, you realize that solid pressure is dependent on the area of contact. Okay, but liquid and gas pressure are independent of the area of contact. Okay, which I'm going to explain later. Then moving on, solid pressure is dependent on the pressure is dependent on the whole weight of the solid resting on the contact area, but for liquid and gas, it's only dependent on the depth of the liquid or the gas above the point of measurement. Okay, it's what is directly above, and it depends on the depth rather than the whole weights of the liquid and gas. And then next, all three states are dependent on the gravitational field strength of the planet. In this case, of course, is Earth. All right, if we are on the Earth. And lastly, the last part is that for hydraulics, okay, only liquid pressure is applied in hydraulics, but the idea of hydraulics is quite different from that of the other parts of pressure that you have learned. Okay, so before I carry on, I just want to stress is that whenever you see the word fluids, all right, it refers to both liquids and gases. All right, so sometimes I will just use the word fluid, and it means either liquid or gas or both. So how I'm going to teach these three lessons is basically trying to answer some of the frequently asked questions after you have go through one round of studying pressure. Okay, so the first question that normally comes about is, why is pressure of fluid, which is liquid and gas, not dependent on the contact area? Okay. Second question is, if pressure of fluid is not dependent on the contact area, what are the factors affecting this pressure? Okay, so we move on. Third one is, why ideas on hydraulic is so different from other pressure questions. Okay, as you know that the formulas in hydraulic are very different from that of the other parts of the lesson. Next, how to understand the idea of atmospheric pressure. Okay, some students don't really understand how do you conceptualize how the atmosphere acts pressure on the person. Okay, next, what is mmHg? Is it a unit? If it is a unit, how do you do conversion? Okay, and then lastly, how do you understand the ideas behind barometers and manometers? So in this first lesson, we are going to deal with the first two, okay, part 1 and part 2. So in the subsequent lessons, we will deal with part 3, 4, and 5, 6. Okay? So, first question. Why pressure of fluid is independent of contact area? So, I just want to run through a nutshell of how I can explain it, and then later I will demonstrate the explanation. So the first point to note is that liquid and gas molecules are not held in a fixed position by strong forces. Okay. Second idea is that the weight of the fluid acts vertically downwards. So only the volume of fluid that is vertically above a contact area acts on it. Fluid elsewhere acts outside the area, because fluid elsewhere is not held together by in a rigid body, so it doesn't act together. But in contrast, in solid, because the whole weight will act on the contact area, because the solid molecules are held together in a fixed position, so they act as a single body. Right? So that is the gist of the difference between solid, liquid, and gases. Alright. So if you are still confused about this, I'm going to use a diagram to explain this. So imagine you have a cup, alright, and you have a liquid. Okay. For convenience sake, the liquid is transparent. So imagine there is a liquid that is filled to the brim in this cup. So the question is, what is the pressure of the liquid is exerting on the contact area below? How are we going to solve it? Alright. So first of all, you need to know is that because this is a liquid, so the weight of the liquid that is going to exert any pressure on the contact area is only the region that is directly above it. So if you draw a region that is directly above the contact area, you will form a shape that has the same area, cross-sectional area, as the contact area. So in this case, if your contact area is circular, you will form a cylindrical shape all the way to the surface of the liquid. So that means that only this region of liquid is acting a force or a weight on the contact area. So what about those outside this region? Okay, on the right and on the left. Those outside this region will act on the side and not on the contact area. Alright, so because liquid is not a solid body, these molecules are not bound to the molecules next to each other, so they don't act as one body. So these molecules will only act downwards on this surface, which is not the area under consideration. Alright, so first we establish that it is only this region above it, then we can proceed to do the calculation. Okay, so the most important thing is only weight of the liquid above the contact area acts on it, and in this case, because the region is a cylindrical shape, so we draw this shape because the contact area is also cylindrical. So since pressure is equal to force over area, or divided by area, we can also say that it is equal to weight divided by area, because the force exerted by this column of liquid is its weight. Alright, and then you know that weight is equal to the mass multiplied by the gravitational field strength of Earth, so you get mg divided by A. So your weight become mg divided by A. Alright, then we can further break down the m into density times volume, because density equal to mass divided by volume. So mass will be equal to density times volume if you bring this over. So you get density volume G divided by A. Alright. Then lastly, you realize that the volume can be further broken down into the height of this column multiplied by this area, which incidentally is the same as the contact area. So you get density multiplied by the height multiplied by the area multiplied by the gravitational field strength divided by area, and you realize that this area and this area cancel out, alright, because they are two of the same. That's why liquid and gas pressure is independent of the contact area, because the area will eventually cancel off from each other. So what you get is just H rho G. Okay, so that's how the formula is derived. Okay, so let's move on. So now that we learned that it is independent of contact area, so what are the factors that fluid pressure are dependent on? Okay, so how do we answer this? Very simple. They are only dependent on what the formula says. So now we establish that fluid pressure is dependent on this formula H rho G. Then obviously it's dependent on these three items in the formula. First, H. I would like you to memorize it as depth rather than height. I will elaborate on this in later, but it is more important to think of it as a depth rather than height. The deeper the point of consideration, the higher the pressure. Okay. The second is of course density. If you have a denser liquid, you will have a higher pressure. And lastly, gravitational field strength of the planet. The greater the G, the higher the pressure. Okay, so these are the only three factors that fluid pressures are dependent on. So let us test ourselves. So the first question is, containers A, B, and C are filled with same liquid. Which has the highest pressure at the bottom of the vessel? I would like you to pause the video at this point in time. Guess your answer before you forward the video. Okay, so have you guessed your answer already? Okay, so the answer is C. Why? Because pressure is only dependent on depth in a fluid, and C is the deepest column in the liquid, hence above the bottom of the vessel. B is the second and A is the lowest pressure. Take note that liquid pressure is independent of the contact area. So I don't care that A is big in the contact area and B is small. I don't care about that. I just care about the depth. So C is the deepest, B is second, and A is the shallowest. Second question. Containers A, B, and C are filled with the same liquid, which has the highest pressure at the bottom of the vessel. Okay, pause the video now and think of the answer. Okay, so have you thought of the answer? Okay, let's move to the answer now. The answer is all the three containers have the same pressure. Why? Because they have the same depth. Remember, fluid pressure is not dependent on the cross-sectional area or the contact area, but only the depth. Okay? Let's move on. Which container of liquids has a higher pressure? Okay, they have different density. You can pause the video now. Okay, so have you guessed your answer? So let's look at the answer. The answer is B, because it has a higher density. Take note that both of them have the same depth. So and also that the liquid pressure is independent of the contact area again. Okay, so only the density is the main factor. Question 4. Two containers of identical liquid. One is placed on Earth, the other on the Moon. Which has a higher pressure? Okay, you may pause the video now. Okay, now let's see the answer. The answer is A, because A has a higher gravitational field strength as it is on Earth. Earth has a higher gravitational field strength than on Moon. Okay, they have the same depth, So that's why the only factor is gravitational field strength. Lastly, this you will need a calculator. So I want you to calculate the pressure at the points A, B, and C in the pond. Okay, take note that the density of water is 1000 kg per meter cube and G is 10 Newton per kg. You may ignore atmospheric pressure. Okay, there's only one hint that I'm going to give you, is that you must really use the idea of depth rather than the idea of height. Okay, you may pause the video now and do your calculation. Okay, let's look at the answer. So first of all, for point C, okay, if you use the idea of depth, you realize that point C is at a depth of 5.5 meters from the surface. Alright, so that means that your answer will be H rho G, which is 5.5 times 1000 times 10, which gives you 55,000 Pascal. How about point B? Point B, again, you must be careful because this is the point where most students make a mistake, because some students will think that this H represents how high B is from the bottom, which is wrong. Okay, you must always remember that this H represents the depth, which is how deep B is from the surface. So if you always remember H as depth, you will not make a mistake. So B is the depth. B is how many meters? 3.5 meters from the surface. So the answer for pressure at B will be 35,000 Pascal. And lastly, using the same idea of depth, you will know that A is definitely 2 meters below the surface, and so the answer is 20,000 Pascal. Alright, so I've come to the end of the first lesson. So we have covered about why is fluid pressure independent of the contact area, and also what are they dependent on, and also did a small quiz. So stay tuned for the second and third parts of the lesson, and I hope that after you have viewed all 3 lessons, you will have a better idea of pressure. Thank you and have a nice day.